So just give you a little background. So for the Before BC Rail Jam, I did some research, sent them an email. They sent me back some information. Really cool. So like I said, $30,000. They use that money to support something called Chasing Sunshine for breast cancer survivors. So people who survive breast cancer, go through all the cancer treatments. There's a lot of like emotional support that they need, as well as future well-being, ways that they can be healthier. Okay, so maybe breast cancer, the cancer doesn't come back and stuff like that. So what they do, they have these retreats, and they're about $2,000. And they're all over the nation. So it's pretty cool. They send up to 120 people every year, this one foundation, to these different retreats where they can go and focus on their health, focus on their physical and mental health.
Would the $2,000 be like per person? Or,
That's per person. Yep. Focus. Come on. So the Before BC, at 0 people, how much money do they have? $30,000.
That's what I thought. I didn't write that. Wait, that's what I wrote before, and then I erased it all. Cool.
And then we know that after that, they start losing money, right, out of this $30,000 that they raised. So let's say 5 people go. They send 5 away.
10,000.
How do you know it's 10,000?
Because so I did 5 times 2, and that was 10, and then I did that in zeros. Because,
So that's 10,000. So what are they at for a total over here now? 20,000. So like I said, last year they sent 120 people away for these retreats. This year, from this one event, they're going to be able to send how many people? 15. So 15 cancer survivors will be able to go to these retreats from this one event. Last year, like I said, they raised 20,000. So this year they're able to send 5 more people than they were last year from Copper Mountain. So now we got to think about our scale factor for our x and y axis. I want you to talk to your tables. What's your independent and dependent variables that you'll be using here? Talk to your tables.
Well, the independence is the people, and the money is the dependent.
How do you know the money's the dependent?
Because the money depends on how much people there is.
Okay. And what are you thinking for when you go to create your scale for your y-axis, which is a dependent variable? What are you thinking for a scale? What does it have to go to? What does it have to go to, Hazel? What does the scale have to go to on your y-axis?
15.
Like when you go to your graph, right, you're going to have your scale on this side. What's the highest value it has to go to?
15.
Are we going up by 5?
The y-axis.
Oh, 30,000.
30,000. Wow, gosh, we just made it too low. So frustrating. I got 2, 4, 6, 8, 10. Oh my gosh. All right, so I can't touch my x-axis because it's done it 3 times. I keep trying to. So here I have my y-axis. I've asked you to talk about dependent, independent variables. So which is which? What do you got, Harper?
Well, for money, I did dependent variable because it depends on the people for how much money it's going to cost.
Okay. So over here, if I have money and I've got 10, 20, 30, I've labeled it dependent variable. What else might I put over here if I have 10, 20, 30? Yeah? Okay. So up here I could put thousands. Or I could put all the zeros, right? I could do that as well. But oftentimes you'll just see it go 10, 20, 30, and it will say in thousands. So this is my independent. Oh my goodness. Holy cow. All right. It's a test of patience. Okay. So this is my x-axis is my independent variable. And what might be the scale on my x? Yeah.
I did ones, just by one.
Okay, because do we have enough?
To get to 10, yeah.
Do I have to get to 10?
No.
I got to get to 15.
I did 2.
Oh, yeah, I did two.
So wait, you did 2s?
Yeah.
Does that work?
Yeah.
Because our lowest is 0, our highest is 15. Because at that point, they're out of cash, right? Everyone, no more cash for any more retreats. So go ahead, share at your table what your graph looks like and explain why your graph might look that way. Go.
Start top left.
Ooh. You guys might want to talk to Brady some. He might need a little support here on this one.
The x-axis is the cost, and the y-axis is the dependent. And the y-axis is the people, because I did that because the x-axis, like, they have a certain amount, and the y-axis, so they have, well, the y-axis is the dependent, I'm getting confused.
Dependent variable.
Yeah, the dependent variable, because, the x-axis is the dependent variable because they're only given a certain amount of money, and they can't go over that, and then they...
But what depends on the other? The cost of how much money they have depends on what?
But you can't send more than you, so you can't be like, I'm going to send 20 people, and then you spend over that.
So what kind of relationship do we have right here? Is this is it a linear relationship?
Yes.
Okay, so if it's linear, there's a rate. What's the rate?
It is...
10,000.
Wouldn't it be...
5,000. Wait, no. It's 10,000 for every 5.
10,000 for every 5. So what is the rate? $2,000, right? Okay. So for every person I send, what happens to my money?
It decreases.
It decreases. So if you're thinking about your graph, what is that graph going to look like? Is that going to be a graph that is, so if you're there, is it doing this or is it doing that? Aha. So it's starting high and then it is decreasing. Okay, get it down. Right, so I was talking, Trey mentioned, he said, well, your rate, he's like, your rate, this is a linear relationship. He said, your rate is for every 5 people, it's $10,000. So I know that if I have a change in Y over change in X, this is my X, and you guys can label this on your paper. That's my Y. This is the independent variable. This is the dependent variable. So my change in Y would be 10 over 2, which then equals that $2,000 per person. So there is a rate here. So this is going to be a straight line, is what Trey said. What kind of line is this going to be? Increasing, decreasing?
Decreasing.
Why is it decreasing?
Because the money is the money.
Because they start with so much, right? They're starting with that 30,000. And then for every 5, they're going down 10. Oh. You know what? Right when I was right about to push it, I was like, and then, darn it. So, wow. It seems like my computer has a mind of its own because I fixed something and then it's this thing down here. All right, so I have this decreasing relationship, but I'm not going to go any further than that. So I have a decreasing relationship. So what does the 30,000, this point here, what does that represent, talking to your table? Okay. And then, in this situation, when this line crosses, when it hits the x-axis, what does that represent?
When it hits rock bottom.
What do you mean by that?
When they run out of money.
When they don't have any money. So this is where they're starting with money, because that's what this variable over here represents. This y-axis represents their money, so this is what they start with. When it hits the x, boom, they're out of cash. Okay, today we're looking at still determining if the relationship is increasing or decreasing. We're going to continue that. This is day 2. Remember, we do have a quiz tomorrow. If you work hard today, this is a great day to prepare for it. Mathematical reflections are going to be due on Monday. We're going to homework. Abba's over there. Please take your paper. Jace is over here. You got on the homework.
Yeah, and just like in general,
Make sure you grab your homework.
Why did he give it to me?
Trying to kill me.
Anna didn't want to do it.
Okay, so I said you messed up. Okay. Down. Of course I know. Okay.
Connor, look behind you.
Okay. So, the first question is how much money? How much money? Okay. So, it's like how much does she start with? And she starts with $20. Okay. She spends $2 each day because on the first day she has 20, the next day she has 18, and then 16, and then it goes on from there.
It's a boy.
Huh?
It's a boy.
It's a
boy.
whatever.
It's okay.
Sorry, I'll
It's a man.
Okay.
It's okay though.
Continue.
Is it linear?
Oh, yes. Yes.
This homework wasn't that hard.
Except for E, I couldn't figure it out.
Oh, D? Yeah, I didn't even do E.
I said y equals 1 minus 2.
Why'd you put D and M?
I'm right there.
Days and then money.
Good job,
I
Jace.
should have read more.
What did you get?
Any other questions? Come on, guys. Stand up, Jace. Right there. He's ready. Come on.
It's -2 or -2.
This is not working.
It's fine.
Don't be
No.
shy.
What?
I don't know how to do
Change the D and the M on your writing. Because now we have no idea what it is.
Wait, is that the right equation?
So, hey, Hopper's asking a question. She's not understanding how you're getting the x times -2 equals y. So, can we explain to her how to, use your graph or go for it?
So, Harper, the X is...
need to see the book.
Yeah.
I'm so confused.
So, I will be answering the question.
Okay.
Well, I need to look at it.
The X, so the X is the days, like the days, and then the -2 is how much she spends, and then that equals how much money she has left.
But if you did like 20 times -2,
True.
you get -40.
True. So that's like minus 2.
You get -40.
But then they'll be in debt -$40.
Wouldn't it be wouldn't it be X plus -2? Because when you add it together, it's like subtraction positive. It would be X plus -2.
I said y. Guys, I said y
-2.
-2, but you know it's
Well, actually, no. The unit is 2.
y minus.
But
I said y -2 is the same thing as.
You guys keep working over there. Kids here? Yep, there we go. Right there.
-2 is the same
Keep
thing.
going.
Why is this
Minus plus negative.
Here, let me have a calculator.
But I got you just tried way too hard. It's really simple.
Here, give it to me.
yeah.
No.
Okay.
You just
So X is what? X is days? Okay, so I'm gonna put 3 days in.
So when you add a negative, you're just getting taking 2 away. So it's X.
Don't pop it.
Actually, negative
X plus.
Yeah, no, that's not right.
Wait.
I'm not good.
No, it's Y. Wait, which one's Y?
Y would be the money. Okay, so it's Y minus 2, because 20 minus 2 equals 18. 18 minus 2 equals 15.
Don't be doing that.
Look, I wrote that down. I got it.
Wait, so what would it be?
Y minus 2.
Because I got it right first when you subtract 2 from Y, you're not getting X. X is the amount of days, so you're wanting X first. X has to be first.
That's what's so hard about it, because, like, you can't do 1 times 18 equals 18, but 2 times 18 doesn't equal 16.
So it sounds like you guys understand that once you have an equation, a way to check it is to put in answers, numbers to the answers to already. You know already from a table or a graph.
Yes.
Okay. And I noticed that a lot of the conversation started when Abba took away her variables that matched the context. When you change it to X and a Y, it seems like things got more confusing. It seems like when you're using, what was it, money and days? M and D. It seems like when you're using M and D, it made more sense to me because it matches the context, right? And Abba explained in her explanation what the M and the D were standing for.
So do I change it again? I'm going to.
But it's helpful.
3 times 7.
Can you rewrite that?
Wait a second.
So Abba, can you put your equation up and then show us how it's checked?
The first equation that I had. So this is.
Did you have the picture of 2? Did you have positive 2? Okay.
That's what I have the first
Okay.
one.
And how can you check that?
If you have a negative rate, is your grade flip right?
You can use a calculator.
Yeah.
Where are you going to put the calculator?
So you can put a day.
Why does that graph look this way when you know it should look
Times 2.
What do we end up doing wrong?
Well, you have to do 2 and then the negative.
What do we end up doing wrong here? Does that make sense, Daniel?
Yeah. I mean, I got negative 10, so if you put a positive 2, that's right.
So you had a positive 2. So if you had a positive 2, yeah, that would be right? Okay.
Yeah.
Well, that
Okay.
makes sense why that would look
Okay.
different than that, right?
I get it.
They're spending $2.
D times 2,
Right.
6 times 2 is not 8. It's 12.
2.
Well, that just worked for that equation. This is what I don't
Have
get.
we talked about how many times you need to establish a pattern?
How many times?
More.
Say it again.
3.
3.
3 times to establish a pattern. So would you pick 3 different points to see if your equation works 3 different times?
Yeah.
Okay.
But if it doesn't work every time, then it doesn't work.
It'd be negative then.
Well, like, it doesn't work all the time.
So we want to check 3 times.
Well, it doesn't work on the one.
Yeah, it doesn't work.
Okay.
I get negative 4. That's not right.
No, he spends yeah, every day. That's not
Yeah.
so
I know. I've had it.
Alright, we're gonna. Alright, guys. Come back to your seat. Get your homework out. Turn to page 20. Okay, homework out. Page 20. So D was causing some confusion here. And I saw the confusion over here as well. So it says write an equation that represents the relationship. What kind of relationship do we have here, Connor? What kind of relationship is it? Is it a positive relationship where my graph Jeez, I can't believe it. I just cannot restart my computer. Just never shut it down. Is it a positive relationship that looks like this? I mean, a negative relationship that looks like that, or a positive relationship that looks like that? Okay, so we know our graph is going to look like this, and we know we have a negative relationship. So what is the rate that's going to make that straight line?
The negative number that
Okay, so what is that negative?
Negative 2.
Okay, so we are looking at our table. We can establish that it's a negative 2 rate. How does that negative 2 work? Like what? Let's build on what Tyler just said. She said that it's a negative 2 rate. But when do you take away 2 more?
Next day.
Every day. So for every day we got 2. So that means this rate is going to work with this right here. Now maybe you labeled it D. It could be X. It is our independent value. So now I have a negative 2 times every day. Okay. What times every day? Okay. So what's that going to equal? It's going to equal your Y, right? That's going to equal the amount of money that you have. Okay. So I should be able to put numbers in, right? To get answers coming out. So here's my X. I can take any of these numbers. I put 2 in. What's 2 times negative 2? Negative 4. I go 2, but it's 16. Talk to your tables. What am I missing here? Go.
Money left equals.
Say it again.
You have to add plus 20.
So, the other day we just briefly talked about this. Okay, yesterday, where this is our rate, and this is something called our y-intercept. So, Daniel hit it on right. He's like, wait a minute, that line is going to touch my y-axis here. And he's like, I start with $20. So how would I work the $20 into here so when into this equation? Harvard. Go.
Plus 20 at X times Y. How do you do that?
So, I have a question. Would you, for the days, like if you were multiplying negative 2, you would just leave the days as a positive number, right?
Yeah.
Okay.
Yeah. 5 days. So Tyler just asked, so is X positive? And then look up here. Tell me, is X positive? Yeah. So 5 days. I put a 5 in. 5 times 2? Negative 2? Negative 10. Negative 10 plus 20?
10.
Bam. So it's thinking about how much money are you starting with? And another way to think about it is, where does that graph touch the y-axis? Can you think of anything else?
At this point, no.
Those are the 2 big concepts.
Have them circle back and talk about the warm-up. I think it's right equation.
Mm-hmm.
Okay, that's what I got.
All right. I would like you guys to go ahead and we're going to move ahead to working on these problems. Go for it. Try. Head up. We're going to go back here.
Maybe on this side.
Okay, guys, make sure you guys having discussions. Okay?
Alright. Great. And we can't do anything bad. Okay. So I don't have enough room on this. Me neither. I gotta get new paper. Well, it doesn't even see my words or yours. Such for you guys. Can't even see me. Okay. Let's see here.
You guys should be somewhere on B, right?
Yeah.
Okay.
We're on B3.
Okay, make sure you guys are reading the problems. right? You have the mic. Read the problems. Work on them together.
Do you need some help, Hannah? Okay, so B2. Wait, you're on B2 or 1? So you want to just look at my table and I'll explain. So it says to make one of the first 10 weeks, and so can first 10 weeks. Thanks. Yeah, first 10 weeks. So just do that and then. Okay,
I'm just drawing it off my paper.
that works. Cool. And then you have to explain why the table is linear. And I thought it was because which is 10.
B.
So you guys are on problem C? Or B3 on B3? Yes.
Write an equation that models.
Write an equation that models the linear relationship. Explain what information each number and variable represents.
Isn't week Y? The Y?
Yeah, week is Y. So
How do you make that decision?
because that's this. Wait, no, that's X.
Oh,
Sorry.
making sure.
Okay. Write the equation that
That
models.
didn't answer my question still. How do you know?
What?
How do you remember which is X and which is Y?
Because the money depends on the week. I don't know.
What strategies are other people using right now to remember which is my X and which is my Y? Help your partner out here.
The alphabet.
That's how I
Y comes before X. So Y.
And I remember because it's horizontal, vertical, and H comes before B, and so I remember X comes before Y. That's how I remember it. Other strategies? Anyone else who's also confused and has a hard time remembering? No? Got it.
I mean, sometimes, yeah.
Okay.
Okay.
So we have our X's. What then, Hannah? The week? Is that what you said?
With what?
The week would be our X. And the money would be.
Okay, so
Okay.
define books, right?
So,
So we know, and I'm going to be making this anchor chart.
do you know why the table is linear?
We know that it's going to be something like.
When you're at a rate of 10.
Okay.
Yeah, that's what we thought.
Which one of these is dependent variable?
So when you do an equation,
Yeah.
X. Oh, it's on me.
Okay.
Write the equation that models linear
Right, 'cause that's dependent
Do you
variable.
have your table?
You said week is
Explain
there.
what information each
It'd
number,
be X
And I'm
times.
going to multiply that by the
Or maybe, I don't
frequency.
know.
the linear relationship. Where's our table?
Is it
Would be-
per week, right? Spend $10. Did I say buy one? Okay. So what kind? If you're spending, what kind of rate is that? Positive or negative? Okay.
Carter, do you have your
So
table?
now
Oh, yeah.
this y-intercept, where does it?
Okay. I want you guys to talk about your tables for a second. One of you has your table set up differently than the other three. And I want you to talk about why that one would make sense over another. Can I see? First? So you guys put them here in the center and kind of look. Carter, don't complete it anymore. Look forward. So let's talk about the setup.
I agree with that.
So then every week we're spending $10. So 2 weeks, how much money do they spend?
I agree with yours, Hannah, except for it's supposed to go a bit longer to 10, but I mean, you got the gist of it, I guess.
I don't want you to do the numbers. Look at the setup. How is it organized? One of you is organized.
Mine's way different.
How is yours organized differently?
Mine's on the opposite side.
Okay.
Yeah.
So which variable do you have on the left, and which variable do you have on the right?
I have weeks on the left.
And I have weeks on the right.
Weeks on the right.
How would we want to do that?
Which one is X and which one is Y?
Okay.
The weeks are X.
The before.
And how do we typically want to organize our table? Don't nobody raise anything. We haven't come to any consensus.
We want to organize our table.
With the models we've seen so far, how are we organizing with our X and our Y? With the ones in the book or the ones from the warm-up tape Mr. McFarland gave us?
Oh, yeah. We're doing, I don't remember. I know something with independent and dependent or X and Y, but I don't remember which side.
So X starts with a positive, how much money?
X goes on the left.
So here's an example here in our book.
Because I'm multiplying negative, and then you count from it.
Do they have the X or the Y first?
They have the X.
Okay, so let's make sure it's not random. Look for a pattern, right? So let's look for two other places where you've seen tables that were given to us. Does it matter if I have my X or my Y?
That's wrong.
Yeah, the week.
On this one it also has an X on the
So it's just supposed
left side. So the X is on the left twice. Look for another example. Look in your book for another example of a table. You found one, Carter. What did you find? Okay, in that table is the X or the Y on the left?
And just all you need. And just do that. And then, yes.
I could if there's a graph.
So when it says sketch, Anthony, it's like they're not asking.
Time going to depend on the distance or the distance depending on the time?
Distance depends on the time.
So then that means... So 3 different times we found a pattern that X is on the left, right? Yeah. Okay. And we don't need to correct the table that we did, but going forward we do want to notice that, right? Yeah. That's how things are organized, because that helps us. If we come to one in a new situation, we're like, oh, it's a table. What's on my left is my X, what's on my right is my Y. That's a standard. Something you can expect. Okay?
Okay. So now is everybody on D3?
Yeah.
Or have you already done that, Bobby?
Okay. And what's my
Pretty
X?
much on that.
Okay, cool. So, what does everyone think?
Now,
Write the equation. So 2.
Here's the problem, though. You just want to, I know.
Okay, so it's going down 10.
Yeah.
So it would be Y equals.
So I'm adding this 100.
That don't really
Wait, no.
matter.
Y.
Is it want to be X equals?
Y times negative constant rate, which is 10, equals X.
Are you sure it's Y?
Yeah, I'm not sure actually.
The table makes me think that it's X, but the graph. We're kind of all over the place at the moment, aren't we? That means we're multiplying the money.
Oh, the amount of money. Yeah, I think that's right because we're going. The week isn't going down.
Oh yeah,
the money's
it's a
going
negative,
down.
so the money goes down.
Yeah, so
It all depends. Like,
let's see if it works.
if my graph
100 times
Negative 10?
10. Yeah.
Wouldn't that make it 0?
Yes, it would. Okay, I'm going to do 20 times negative 10.
So this would be, I'm saving $10 every week.
Wait, so when you multiply negative,
And at one point,
It goes down by 10. It's like,
so that
okay,
oh wait, doesn't that turn it into a negative?
let's say he was given a gift by his dad.
I don't remember.
Now, the gift was $50.
I think one negative makes it a positive, 2 negatives makes it a negative. So I think it'd be a positive.
Oh, a positive times a negative equals a negative.
Every week.
Oh yeah. Positive times negative equals negative.
So after week 1,
Multiply it by a decimal maybe?
2, 7. Right?
Okay, 20 times negative 10 equals negative 10. So that algorithm isn't right.
That's exactly. That's a really
What
good way
do
to think
you
about
think
it.
the algorithm could be? You can't.
It's gonna be 3. Maybe it would be
I think we have grading
negative 10 times x plus something.
I think You're on the equation?
Yeah.
Okay. So, oh man, you were so close. So we know it's a negative $10 every week, right?
Yeah.
But what is she starting at? 100. So what do I do with that 100 in my equation? You add it. So now look at your equation and see if it works. Like after 1 week, how much money is she going to have? $90, right? Because it's going to be 1 times negative 10. Negative 10. Negative 10 plus 100. 90. Is that so? Hannah, rock star. Woo. Love it. Yeah.
So this is not math.
Boom, you nailed that equation. Oh, you missed. No, you only missed this. Right, it's got equal cash. All right, what's up?
It's off topic.
Okay, hold on then. I don't want that.
We're writing an equation. X always has to represent 3. 1.
All right, guys. Can you guys please go ahead. Put your learning away. I love it. I had 4 groups. We're on C. And you guys really did a good job on B, but we might come back to that if you have enough time. Abba and Jace, can you make sure you guys, after we're done talking, you always erase your boards? So we got 14 A and B. Hey, Jace, can you erase that? On page 20. So come on, planners out. Remember this, I am doing my job right now, which is telling you what the homework is, giving you an opportunity to write it down. If you've got your planner, that's the best spot because it has dates and everything. It's easy. If you don't, maybe you have your own system. Maybe you want to spend more time at home looking it up online, figuring out what it is. That's fine. 14 AB on page 20. My suggestion, do those 2 problems. You will see something very similar on the quiz. I can promise you that. Okay? So there's going to be, that is a really good question. Ty.
So, for the extra ticket, it's asking to write one equation he could use using the...
You don't have to write the equation. You got to write a question. So let me get to it. It says Reggie's looking forward to the walkathon. He's doing the walkathon too. You guys haven't heard of him. He's a nice guy. He's raised a bunch of money. You can see. He writes an equation to use to answer some questions. About the walkathon. I don't know where that came from. Anyway, I'll fix that. Write one question he could use the equation to answer. This is a different kind of, I haven't asked you to think about equations and what do they answer, but I think you know what they answer, I just haven't specifically asked it. So here's his equation. What kind of question would he have that he could use the equation to figure out? I want some independent struggle time here, so some productive struggle. So we're going to do some independent thinking because we have time. If you think you're like, ooh, I got a question. I know a question he could ask that would answer. Okay, and I'm just going to make a few modifications to this to give you a little scaffolding now. Maybe that will help you figure out what kind of question he could ask that the equation would help him figure out. Well, no, not yet. Independent, productive struggle here. I like what Trey's done. Trey wrote down the equation on his paper. That's a good start. He's thinking about what he knows. That's another good start.
I like Ava. Her question includes really understanding the context of the equation.
Okay, share your tables. Ooh, try to even get more specific because that's a yes, exactly. Boom. How much?
20.
He doesn't have to walk at all.
8.
Yeah, there we go. Right? Because that's what.
How much money he can make after walking.
You want to share yours?
I had it in my head.
Hey, Jace, will you share yours now? All right. Going back to Jace. So, Jace, go for it nice and loud so we make sure we get this.
Okay. Reggie could ask how much kilometers he has to walk to get $80.
Boom. How many kilometers does he have to walk to make $80? That equation is going to help him answer that question. Okay? Did anyone else have a different question maybe? Yeah.
How much money are you raising per kilometer?
Let's get even. Yes. Yeah. How much is Reggie raising per kilometer?
$3.
$3.
Plus 20.
Plus the 20. Well, the 20 is like a add-on, right? But per kilometer, $3. That's a good question. I didn't even think of that kind of question. That's good. Anybody else? How about this one? If Reggie walks 10 kilometers, how much money does he earn? Right? Okay. So, next. I disagree with you on that because... All right. So, label the equation. I want you to make sure you have this equation. Label it with the dv, dependent variable. Which one is the dependent variable? Which one is the iv, independent variable? What is the y-intercept and what is the rate? And then you may go, but you need to share it with 2 people at your table. No.
That I won't
I
ask
had a soccer meeting on Monday. Last night I had our CCU board meeting. It's been a crazy soccer meeting. Two, because we're gearing up for the competitive season. And so I'm meeting it's a lot. And then once the season starts, it's just like, then I'm into like just coaching. I still have these meetings that go until like 9 o'clock at night.
Presley kind of did 2 hours last night. I was exhausted. We were all like,
2.5 hours we spent on the meeting talking about all the soccer.
I like meetings. Did you look at last year's yet or anything? No, nothing.
I didn't get this one last year because I was so
Okay.
But I can show you what it is. I am going to.
So I said, y is equal to variable I.
Yeah, see you guys later once you're done.